The Second World War had ended, but peace did not truly arrive. The Soviet Union emerged victorious, yet the scale of destruction was immense. Entire cities lay in ruins, tens of millions were dead, and the economy was exhausted. Society had adapted to survival under extreme pressure, and that pressure did not disappear with the end of the war. For the Soviet leadership, the future was no longer an abstract concept. It became a matter of survival. The post-war world was rapidly dividing. Former allies were turning into rivals. The United States possessed nuclear weapons, long-range aviation, and an industrial base untouched by invasion. The Soviet Union, by contrast, relied on mass mobilization, centralized control, and a willingness to sacrifice present stability for future security. A new conflict did not yet have a name, but the silence between the blocs was already filled with suspicion. It was within this silence that the foundations of the Soviet space program were laid. At its core, space was not initially about exploration. It was a continuation of military logic beyond the atmosphere. Rockets were already seen as strategic weapons, capable of reaching targets across continents. The step from ballistic missile to space launch vehicle was not conceptual, but functional. The technology was nearly the same. Only the destination changed. This connection was quickly understood. If a rocket could deliver a warhead thousands of kilometers away, it could also place an object into orbit. If it could leave the atmosphere, then, in theory, a human being could follow. Space was not imagined as a dream, but as a technical extension of existing capabilities. There was also a powerful symbolic dimension. After the war, the Soviet Union needed more than economic recovery. It needed a vision of the future. Victory over Nazi Germany had provided moral legitimacy, but that legitimacy was temporary. A new narrative was required, one that could compete with the Western model of prosperity and freedom. Space offered something unique, a future that was distant from everyday hardship, visually compelling, and difficult to challenge ideologically. A rocket launch could not be debated. It either happened or it did not. Physics was immune to propaganda. At the same time, space remained largely unknown. No one fully understood how the human body would react to weightlessness. No one knew whether a spacecraft could return safely. Even the boundary between atmosphere and space was still a subject of debate. This uncertainty mattered. It meant that no nation possessed a decisive advantage based on past experience. For the Soviet Union, this was an opportunity. In areas where Western industry was stronger and more efficient, catching up would take decades. But space offered a rare domain where almost everything had to be invented from scratch. There were no established supply chains, no inherited infrastructure, no proven doctrines. Everyone was starting at nearly the same point. However, the road to space did not begin with stars or planets. It began with military blueprints, classified test ranges, and engineers working under constant pressure. The emerging space program developed inside a system where secrecy was absolute, failure was hidden, and success was tightly controlled. Decisions were made behind closed doors, and mistakes often vanished from official records. From the beginning, space in the Soviet Union belonged to the state. Before a human could leave Earth, the country first had to master the creation of rockets powerful enough to escape its gravity. These rockets were not designed for exploration, they were designed for war. And it was from these weapons that the Soviet path to space truly began. That path leads directly to the origins of Soviet rocketry itself. The Soviet road to space did not begin with scientists dreaming of the cosmos. It began with weapons. In the years immediately following the war, rockets were viewed through a single lens: military necessity. The experience of total war had reshaped strategic thinking. Aircraft could be intercepted, artillery had limited range. But rockets offered something fundamentally different: speed, distance, and the promise of unstoppable delivery. The early Soviet rocket program was built under extreme secrecy. Test sites were isolated, maps were altered, and entire regions were erased from public awareness. Engineers worked under military supervision, often without full knowledge of how their work would be used. Failure was not merely a technical issue, it was a political risk. One figure stood at the center of this effort: Sergei Korolev. Korolev was not a public hero at the time. His name was classified, absent from newspapers and official announcements. Within the system, he was known only by title, not by identity. Yet his influence shaped nearly every major step of the Soviet rocket program. Under his direction, Soviet engineers focused on a single challenge: building a rocket powerful enough to cross continents. The result was the R-7, a massive intercontinental ballistic missile designed to deliver a nuclear payload thousands of kilometers away. The R-7 was not elegant. It was enormous, complex, and difficult to control. It required extensive preparation, consumed vast resources, and failed repeatedly during early tests. But it possessed one crucial quality: power. That power changed everything. For the first time, the Soviet Union had a rocket capable of reaching velocities far beyond what military planners initially required. Engineers soon realized that the same machine designed to carry destruction across the planet could also carry something else: an object placed into orbit. This realization did not immediately shift priorities. Military objectives remained dominant. The Cold War was intensifying, and nuclear deterrence was considered paramount. Space was still viewed as secondary, almost incidental. But the technical door had been opened. Secrecy shaped every aspect of development. Launch failures were concealed, successful tests were reported in vague terms. Engineers were compartmentalized, often unaware of parallel projects happening within the same program. This lack of transparency slowed progress, but also protected the illusion of uninterrupted success. The Soviet system tolerated experimentation only as long as it produced results. Unlike Western programs, which increasingly relied on civilian agencies and open collaboration, the Soviet approach remained deeply militarized. Space hardware was designed in the same facilities as weapons. Personnel were subject to military discipline. Decisions flowed downward from political leadership, with little room for dissent. This structure created a paradox. On one hand, centralized control allowed rapid mobilization of resources. Entire factories could be redirected overnight. Skilled workers were reassigned without negotiation. On the other hand, the same rigidity suppressed critical feedback. Engineers learned to adapt designs quietly rather than challenge directives openly. As a result, many early breakthroughs emerged not from official planning, but from improvisation. Engineers modified military rockets to perform tasks they were never meant to do. Guidance systems were adjusted, payload compartments were reimagined. Step by step, a weapon began to resemble a spacecraft. Not because the system intended it, but because the technology allowed it. Gradually, political leadership recognized the opportunity. A successful space launch offered more than military advantage. It offered psychological impact. It demonstrated technological capability without firing a single weapon. In a world divided by ideology, space became a stage where power could be displayed without direct confrontation. Yet this shift did not reduce secrecy. If anything, it intensified it. Space launches were announced only after success. Failures remained invisible. Even many within the Soviet scientific community were unaware of the true scope of the program. The public saw results, never process. Behind the scenes, Pressure increased, deadlines tightened, expectations grew. Engineers were asked to move faster, take greater risks, and operate with incomplete data. The line between acceptable failure and unacceptable delay became increasingly blurred, and still, no one knew whether sending a living being beyond the atmosphere was even possible. Before the Soviet Union could claim space as a new frontier, it first had to answer a more basic question. Could life survive there at all? That question would define the next phase of the program. By the mid-1950s, the Soviet rocket program had reached a critical threshold. The technology that had been developed for military purposes had surpassed its original intent. Rockets were now powerful enough not only to cross continents, but to reach speeds that made orbit theoretically possible. What had once been speculation was becoming an engineering question. The question was no longer if an object could be placed beyond Earth. It was when and who would do it first. Inside the Soviet system, this realization created a quiet urgency. The Cold War was intensifying, and competition with the West extended far beyond weapons. Prestige mattered. Demonstrating technological superiority without direct conflict was becoming a strategic tool in itself. Space offered exactly that. The idea of launching an artificial satellite was deceptively simple. In practice, it required solving problems that had never been encountered before. Engineers had to design systems that could survive vacuum, extreme temperature changes, and constant radiation. Communication with an object traveling faster than any aircraft posed an entirely new challenge. Even tracking such an object from the ground was uncertain. There were no precedents to follow. What made the effort distinctive was its speed. The decision to proceed was not the result of long public debate or gradual institutional planning. It was driven by a narrow circle of specialists operating under political pressure. Time was critical. Every delay carried the risk that another nation might succeed first. Secrecy remained absolute. Even as preparations advanced, few outside the immediate program understood what was about to happen. The launch site was isolated, documentation was restricted, test results were shared selectively. The satellite itself was intentionally simple, not because of limited ambition, but because reliability mattered more than complexity. The goal was not to gather extensive scientific data. The goal was to prove that orbit was possible. When the launch finally occurred, the impact was immediate and global. A small object had entered Earth's orbit, transmitting a steady signal that could be detected around the world. That signal was simple, repetitive, and impossible to ignore. It carried no message, no ideology, no explanation. Its existence alone was the message. For the first time in history, something built by humans was circling the planet. The psychological effect was profound. In the Soviet Union, the launch was presented as a triumph of science and collective effort. Newspapers celebrated the achievement. The narrative emphasized peaceful exploration and technological progress. Yet much of the true process remained hidden. The public saw the result, not the uncertainty behind it. Outside the Soviet Union, the reaction was very different. The launch triggered shock, anxiety, and urgent reassessment. If a satellite could orbit Earth, then rockets could also deliver weapons across vast distances. The boundary between civilian achievement and military threat became dangerously thin. Space was no longer abstract. It had become operational. This moment reshaped global perception. Space was no longer the domain of science fiction. It was now part of geopolitical reality. Within the Soviet program, the success created both confidence and pressure. Engineers had demonstrated that orbit was achievable, but expectations immediately escalated. Political leadership saw space not as a single milestone, but as a sequence of victories to be delivered on demand. The logic was simple. If an object could be sent into orbit, then something more ambitious should follow. This shift introduced new risks. The same secrecy that had protected the program now limited its flexibility. Failures could not be discussed openly. Design flaws were corrected quietly. Engineers worked longer hours under increasing scrutiny. Each success raised the stakes for the next attempt. At the same time, a new question emerged, one that could not be answered with calculations alone. Could a living organism survive launch, orbit, and return? The vacuum of space, the absence of gravity, and the stress of acceleration posed unknown dangers. No human had ever experienced such conditions. Sending a person without testing would be reckless, yet testing itself carried ethical and technical challenges. The solution was incremental. Before risking human life, the Soviet program turned to biological experiments. Animals were sent into suborbital and orbital flights to study survival, stress, and recovery. These missions were not publicized in detail, but they played a crucial role in shaping the next phase of the program. Each flight answered one question and raised several more. With every successful mission, the idea of human spaceflight moved closer to reality. What had begun as an extension of military rocketry was evolving into something unprecedented: the possibility of a person leaving Earth entirely. The Soviet leadership understood the significance of this step. Placing a human in orbit would not merely be a scientific achievement. It would redefine the limits of human capability and deliver an unmatched symbolic victory. The pressure to proceed was immense, and the margin for error was thin. As preparations accelerated, the program crossed an invisible line. Space was no longer about machines alone. It was about people. By the late 1950s, the Soviet space program had reached a decisive moment. The technical possibility of orbital flight had been demonstrated. Machines could survive launch, function in space, and return data to Earth. The remaining question was no longer technological alone. It was human. Could a person endure spaceflight? No one knew the answer. There were serious concerns. Prolonged weightlessness might cause disorientation or loss of consciousness. Rapid acceleration could overwhelm the cardiovascular system. The psychological effects of isolation inside a small capsule were unknown. Even basic assumptions about vision, coordination, and reaction time could not be confirmed without real experience. Despite these uncertainties, the pressure to move forward was relentless. The Soviet leadership understood that placing a human in orbit would represent a decisive milestone in the Cold War. It would demonstrate not only technological capability, but control over the most complex system imaginable, the human body itself. Delay meant risk. Another nation might act first. The decision was made to proceed. The selection process was shaped as much by politics as by physiology. Candidates were chosen from military pilots, particularly fighter pilots, accustomed to extreme conditions, strict discipline, and unquestioned obedience. They were required to be physically resilient, psychologically stable, and, critically, adaptable to secrecy. Personal ambition was secondary. Those selected entered a program that was experimental in every sense. Training regimes were intense and often improvised. Candidates were subjected to centrifugal forces, isolation chambers, temperature extremes, and simulated emergencies. Each test pushed the limits of what was considered safe. Failure was expected. What mattered was survival and recovery. Medical oversight was constant, yet knowledge lagged behind practice. Doctors observed reactions they had never seen before. Data was collected rapidly, interpreted cautiously, and often acted upon immediately. There was no long-term research to rely on, only short-term observation and calculated risk. Secrecy remained absolute. Even the candidates themselves were not always fully informed. Details of spacecraft systems, mission duration, and contingency plans were tightly controlled. This was not merely a matter of security, it was a method of maintaining psychological focus. Too much information could introduce doubt. The spacecraft designed for human flight reflected this philosophy. It was small, highly automated, and intentionally limited in manual control. Engineers feared that a human might panic or lose cognitive function in orbit. As a result, most systems were controlled from the ground. The pilot was present, but not fully trusted. This decision underscored the uncertainty at the heart of the mission. The individual ultimately chosen to fly was not selected because he was extraordinary, but because he was reliable. He fit the system. He followed instructions. He represented discipline rather than individuality. That individual was Yuri Gagarin. Gagarin's flight was brief, but its implications were immense. The launch proceeded without public announcement. Only after confirmation of success was the mission revealed. The spacecraft completed a single orbit of Earth before returning. Throughout the flight, telemetry was closely monitored, searching for signs of physical or psychological distress. When the capsule re-entered the atmosphere and the pilot returned alive, a threshold was crossed. For the first time, a human being had left Earth, traveled through space, and come back. The global reaction was immediate. In the Soviet Union, the event was presented as a triumph of socialism, science, and collective effort. Gagarin became a symbol almost instantly. His image was carefully constructed, calm, optimistic, and loyal. The narrative emphasized progress and unity. Behind the scenes, the response was more complex. Engineers reviewed data with urgency. Medical teams analyzed every recorded heartbeat, breath, and movement. The success answered some questions, but raised many others. Short-duration flight appeared survivable. Longer missions remained uncertain. Yet political momentum did not slow. Success generated expectation. If one human could orbit Earth, then more could follow. If one orbit was possible, then multiple orbits should be attempted. Each achievement became the baseline for the next demand. This dynamic introduced a dangerous pattern. Risk was no longer evaluated solely on technical grounds. It was increasingly shaped by symbolic value. Spaceflight had become a performance, observed by the world and judged by rivals. The margin for hesitation narrowed. At the same time, the human element changed the nature of the program. Machines could fail without consequence. Humans could not. Every mission now carried not only technical risk, but moral weight. A fatal accident would be impossible to conceal and devastating to public perception. The system that thrived on secrecy was now operating in full view of the world. As the program accelerated, engineers and planners faced a new challenge. Sending a human into orbit had proven possible, but sustaining human presence in space, longer flights, complex maneuvers, and ultimately journeys beyond Earth's orbit required capabilities far beyond anything achieved so far. The next phase would demand more than courage and improvisation. It would demand ambition on an entirely different scale. By the early 1960s, the Soviet Union appeared to be leading humanity into space. A sequence of historic firsts had reshaped global perception. The first artificial satellite, the first human in orbit, the first multi-orbit flight. Each achievement reinforced the impression that the Soviet system possessed an inherent advantage in space exploration. From the outside, the pattern looked deliberate and controlled. Inside the program, the reality was far less stable. Early successes created a powerful narrative of inevitability. Space began to feel like a domain where the Soviet Union naturally excelled. This belief spread quickly through political leadership, the media, and even parts of the scientific community. Momentum replaced caution. Confidence replaced restraint. The system began to expect victories on schedule. Political leaders, most notably Nikita Khrushchev, understood the value of these achievements. Spaceflight offered something rare, a way to demonstrate power without direct violence. Each successful mission became a diplomatic tool, a symbolic response to Western influence. As a result, expectations intensified. Engineers were no longer asked whether something could be done, but when it would be delivered. Timelines shortened. Missions grew more ambitious. Risk assessments were compressed into political deadlines. The program was still technically driven, but increasingly shaped by symbolic urgency. This shift had consequences. While the Soviet Union celebrated visible successes, deeper structural problems remained unresolved. There was no single civilian agency overseeing spaceflight. Instead, multiple design bureaus operated in parallel, often competing rather than cooperating. Information was shared selectively. Coordination depended on personal relationships rather than institutional clarity. Secrecy, once a protective measure, became a liability. Failures were hidden not only from the public, but sometimes from decision-makers themselves. Launch accidents, design flaws, and near catastrophes were quietly absorbed into internal reports. Lessons were learned locally, but rarely disseminated across the entire program. This fragmentation slowed progress in subtle ways. Each bureau optimized its own systems, often without regard for long-term integration. Solutions that worked in isolation became obstacles when combined. The absence of open review made it difficult to challenge assumptions or question directives. At the same time, the global environment was changing. The United States responded to early Soviet achievements with urgency. Investments increased. Organizational structures were simplified. Civilian oversight expanded. While Soviet planners focused on maintaining symbolic leadership, their rivals focused on building sustainable capacity. This contrast went largely unnoticed within the Soviet narrative. Public messaging emphasized continuity and confidence. Successes were highlighted. Setbacks were omitted. The image of unbroken progress was carefully maintained. To the outside world, the Soviet space program appeared unstoppable. Internally, pressure mounted. Cosmonauts were asked to undertake longer missions with limited preparation. Engineers were required to adapt systems beyond their original design parameters. Redundancy was sacrificed for speed. Each mission carried an implicit expectation. It must succeed. The illusion of leadership began to influence technical decisions. Instead of asking what was safest or most reliable, planners increasingly asked what would maintain momentum. Spaceflight became a demonstration rather than an experiment. The system that had thrived on cautious iteration now rewarded rapid escalation. This dynamic masked a critical weakness. While early missions had relied on modified military rockets, future goals required entirely new capabilities. Sustained human presence in space, complex orbital maneuvers, docking, ultimately missions beyond Earth orbit. These demands could not be met by incremental adaptation alone. They required structural reform. Yet reform was difficult within a system built on secrecy and hierarchy. Admitting limitations risked political consequences. Slowing down risked symbolic defeat. As a result, problems accumulated quietly beneath the surface. The belief that leadership had already been secured delayed necessary changes. By the mid-1960s, the Soviet Union still held many records in spaceflight, but the foundation beneath those records was fragile. Progress continued, but direction became less clear. Confidence remained high, even as underlying coherence weakened. The most ambitious objective still lay ahead. Reaching the moon was no longer a distant concept. It had become the ultimate measure of technological and ideological supremacy. And, despite public confidence, the Soviet path toward that goal was uncertain. The illusion of leadership would soon collide with reality. For several years, the Soviet Union had set the pace in space. Early victories created the impression that leadership was secure and that future achievements would follow naturally. But this confidence began to erode when a new objective entered the global stage: the Moon. Unlike orbital flight, the Moon represented a definitive destination. It was distant, visible to everyone, and impossible to redefine. Reaching it would not be interpreted as a technical milestone alone, but as a final verdict in the competition for technological supremacy. The moment that changed everything came not from a launch, but from a declaration. In the early 1960s, the United States publicly committed itself to landing a human on the Moon within the decade. This was not a quiet internal goal. It was announced openly, tied to national identity, and backed by unprecedented resources. The challenge was explicit and time-bound. For the Soviet leadership, this was a fundamental shift. Until that point, space achievements had been incremental and reactive. One success led naturally to the next. The Moon, however, required a coordinated strategy from the outset. It demanded long-term planning, unified command, and technologies that did not yet exist. The Soviet system was poorly suited for such an approach. There was no single authority responsible for a lunar program. Instead, multiple design bureaus pursued different concepts simultaneously. Some favored direct lunar missions, others proposed orbital rendezvous. Still others focused on robotic alternatives. Each path competed for funding, personnel, and political support. This competition was not purely technical. Design bureaus were tied to influential figures within the political and military hierarchy. Success meant prestige and survival. Failure meant marginalization. As a result, collaboration was limited and compromise was rare. Secrecy intensified the problem. Because projects were classified, coordination relied on fragmented information. Engineers working on one system often lacked insight into parallel developments elsewhere. Redundant efforts multiplied. Incompatible designs advanced side by side without integration. The absence of a unified vision slowed progress. While the United States consolidated its lunar ambitions under a centralized civilian framework, the Soviet Union continued to rely on dispersed authority and informal negotiation. Decisions were often reactive, shaped by short-term considerations rather than coherent planning. At the political level, uncertainty prevailed. Publicly, Soviet officials avoided clear statements about lunar goals. Unlike their rivals, they did not announce a definitive commitment. This ambiguity was deliberate. A public failure would be difficult to conceal, and success was far from guaranteed. Privately, pressure mounted. The Moon had become the ultimate benchmark. Remaining silent risked symbolic defeat. Acting without preparation risked disaster. The system hesitated between these extremes, losing valuable time. Technically, the challenges were immense. A lunar mission required a launch vehicle far more powerful than anything previously built. It required precise navigation over vast distances, reliable life support systems for extended durations, and safe re-entry at unprecedented speeds. None of these problems had straightforward solutions. Despite this, work began. Engineers started designing heavy-lift rockets capable of sending payloads toward the Moon. New spacecraft concepts were drafted. Simulations were run. Tests were conducted, often in isolation from one another. Progress was real, but uneven. At the same time, robotic missions were prioritized as a safer alternative. Uncrewed probes offered valuable data without the political risk of human loss. They could demonstrate technological capability while buying time. Several such missions were launched, some successfully, others not. Each provided fragments of knowledge, but none resolved the core challenge. The contrast with the American approach grew sharper. While the United States publicly aligned its scientific, industrial, and political institutions around a single objective, the Soviet effort remained fragmented. Resources were significant, but not coordinated. Expertise was deep, but divided. This fragmentation had subtle consequences. Engineers optimized subsystems without knowing how they would ultimately fit together. Design choices made early would later conflict with emerging requirements. Adjustments became increasingly difficult as projects matured independently. Yet the ambition did not fade. Within the Soviet space community, the Moon retained its symbolic power. It represented not only a technical challenge, but a chance to reclaim initiative. Many believed that despite delays, success was still possible. What they underestimated was the cost of disunity. As deadlines approached and expectations rose, the lack of a centralized program became impossible to ignore. The Soviet lunar effort was moving forward, but without a single direction. Each step forward revealed new contradictions. The race to the Moon had begun, but it was a race the Soviet Union entered without a single starting line. The next phase would expose the consequences of this choice. Every path to the Moon required one indispensable element: a rocket powerful enough to leave Earth with a heavy payload. For the Soviet lunar program, this requirement became its greatest obstacle. The challenge was straightforward in theory and brutal in practice. A lunar mission demanded a launch vehicle far larger and more complex than anything the Soviet Union had previously built. Existing rockets, adapted from military designs, were insufficient. A new class of machine was needed, one that would push engineering, logistics, and organizational discipline to their limits. Work on such a rocket began under intense pressure. Unlike earlier projects, there was no margin for incremental success. The lunar rocket had to work almost perfectly, or the entire effort would collapse. Yet it was developed within a system already strained by secrecy, fragmentation, and political expectation. After the death of Sergei Korolev, leadership of the lunar effort passed to his successor, Vasily Mishin. Mishin inherited not only an ambitious project, but a deeply unstable environment. Authority was contested, timelines were unrealistic, and technical decisions were constantly scrutinized by political overseers. The rocket that emerged from this process was unprecedented in scale. It relied on a clustered engine design, dozens of engines firing simultaneously during the first stage. This approach avoided the need to develop a single extremely large engine, but introduced extraordinary complexity. Synchronizing so many components increased the probability of failure exponentially. Testing, under ideal circumstances, might have mitigated these risks. But circumstances were far from ideal. Ground testing was limited. Full-scale test stands were expensive and time-consuming to build. In a system driven by urgency, launches themselves became the primary form of testing. Each flight was expected to validate multiple unknowns at once. This approach carried enormous risk. The first launch ended in failure, so did the second, and the third. Each attempt revealed new flaws: engine shutdowns, vibrations, structural weaknesses. None of these failures were publicly acknowledged. Official silence surrounded the entire effort. Internally, the pressure intensified. Failures could not be openly analyzed across institutions. Engineers were forced to diagnose problems within narrow compartments of information. Root causes were suspected, but not always confirmed. Solutions were implemented quickly, sometimes without full validation. Time was running out. As the United States advanced steadily toward a lunar landing, the Soviet program faced a stark reality. Without a functioning heavy-lift rocket, no human mission to the moon was possible. Robotic successes could not substitute for this gap. The final attempts were made under extreme constraints. Launches were scheduled not because readiness had been achieved, but because delay was no longer acceptable. Political expectations outweighed technical caution. Each failure compounded the next, eroding confidence and resources. The most catastrophic launch occurred shortly after liftoff, when the rocket lost control and fell back onto the launch site. The explosion destroyed infrastructure and set the program back irreversibly. The scale of the disaster was immense and entirely concealed. No public reckoning followed. There were no announcements, no explanations, no acknowledgement of loss. The program simply continued in diminished form, even as its core objective slipped further out of reach. The failure of the lunar rocket was not merely a technical setback. It exposed the limits of the system that had produced earlier successes. Centralized control without transparency, competition without coordination, ambition without unity. These characteristics, once masked by symbolic victories, now defined the program's constraints. Gradually, reality set in. The moon was no longer attainable within the required time frame. Even as work continued in fragments, the political will to sustain the effort faded. Resources were redirected. Priorities shifted quietly. The dream did not end with a single decision. It dissolved slowly through silence and omission. What remained was a legacy of effort. Thousands of engineers, countless hours, and technologies that would find other uses. The moon, however, would remain untouched by Soviet astronauts. The program adapted. Instead of pursuing a goal that had become unreachable, the Soviet Union turned toward an alternative path, one that avoided direct comparison and reduced political risk. This path would lead not to the moon's surface, but to Earth orbit. By the end of the 1960s, the reality of the Soviet lunar effort could no longer be ignored. The failures were too frequent, the delays too costly, and the gap between ambition and capability too wide. While no public announcement marked the end of the dream, the direction of the program began to shift in ways that were subtle but decisive. The retreat from the moon did not happen abruptly. There was no single meeting, no official cancellation, no statement acknowledging defeat. Instead, the change unfolded through a series of quiet decisions. Budgets were reallocated, test schedules slowed, key personnel were reassigned. The language used in internal documents became less definitive, more cautious. The moon gradually disappeared from the center of planning. This approach reflected a broader characteristic of the Soviet system. Public failure was unacceptable. Success could be celebrated. Absence of success could be ignored. When an objective became unattainable, it was not abandoned. It was replaced. Earth orbit offered that replacement. Unlike the moon, orbital operations did not demand a single massive breakthrough. They could be expanded incrementally. New missions could build on existing infrastructure. Achievements could be framed as progress rather than comparison. Most importantly, orbital projects carried less political risk. A failed lunar landing would be visible to the entire world. An unsuccessful orbital mission could be concealed or reframed. This difference mattered deeply to leadership increasingly focused on stability rather than spectacle. At the same time, the internal environment was changing. The death of key figures within the space program had left a vacuum of authority. Technical leadership became more fragmented. Decision-making slowed. Where earlier phases had been driven by bold initiative, the new phase emphasized caution and control. Political priorities also evolved. Under Leonid Brezhnev, The emphasis shifted away from dramatic symbolic gestures and toward long-term parity. The goal was no longer to shock the world, but to maintain equilibrium. Space exploration became a matter of sustained presence rather than singular achievement. This change aligned naturally with orbital stations. By focusing on long-duration missions in Earth orbit, the Soviet Union could claim leadership in a different dimension. Instead of landing on the Moon, it would remain in space continuously. Endurance would replace distance. Routine would replace spectacle. The first orbital stations reflected this logic. They were not designed for elegance or public appeal. They were utilitarian, modular, and experimental. Their purpose was to study human endurance, life support systems, and the effects of prolonged weightlessness. These were challenges the lunar program had never fully addressed. In this sense, retreat created opportunity. Technologies developed for the abandoned Moon effort were repurposed. Guidance systems, docking mechanisms, and life support components found new applications. Engineers adapted rather than discarded their work. However, this transition was not without cost. The psychological impact on the space community was significant. Many engineers had devoted years to a goal that was now quietly sidelined. Their efforts were not publicly acknowledged. Their failures were not discussed. History moved forward without resolution. This silence shaped the culture of the program. Ambition became cautious. Innovation became incremental. Risk-taking diminished. The lessons of the lunar failure were absorbed indirectly, through institutional memory rather than open analysis. Meanwhile, robotic missions continued. Uncrewed probes were sent to the Moon, collecting samples and transmitting data. These missions demonstrated technical competence, but they did not replace the symbolic power of a human landing. They occupied an ambiguous space, impressive yet overshadowed. The broader narrative shifted accordingly. Space exploration was reframed as scientific progress rather than competition. Cooperation was emphasized selectively. The language of conquest faded, replaced by terminology of research and utilization. This reframing was strategic. By redefining success, the Soviet Union avoided direct comparison at a moment when comparison was unfavorable. The Moon, once a central symbol, became a peripheral achievement. Yet the fracture remained. The dream of lunar exploration had not failed because of a single technical flaw. It had fractured under the weight of systemic constraints, secrecy, fragmentation, and the inability to adapt organizational structures to escalating ambition. What emerged in its place was a different vision of space, one rooted not in reaching farther, but in staying longer. The focus on Earth orbit would shape the next decades of Soviet space activity, influencing everything from station design to crew selection. It was a path chosen not out of inspiration, but necessity. And while it preserved relevance, it also marked the end of an era. The Soviet Union would continue to operate in space, but the horizon had shifted closer. The grand ambition of walking on another world had been set aside, replaced by a quieter, more controlled objective. The legacy of this decision would define what came next. As the prospect of a human lunar landing faded, the Soviet space program pursued a different path. It was quieter, less visible, and far less risky, but technically sophisticated. Instead of placing a person on the Moon, the Soviet Union focused on reaching it with machines. This approach was not a retreat from exploration. It was a recalibration. Robotic missions offered several advantages. They required no life support systems, no safe return for a human crew, and no tolerance for psychological uncertainty. Failures, while costly, carried no moral weight and could be concealed more easily. In a system sensitive to public perception, this mattered. The Soviet lunar robotic effort was methodical. A series of probes were designed to approach, orbit, land on, and interact with the Moon's surface. Each mission addressed a specific technical problem: soft landing, surface mobility, sample collection, and return to Earth. Together, they formed a parallel lunar program, one less dramatic but increasingly capable. These missions were conducted under the umbrella of the Lunar program. Early attempts were inconsistent. Some probes failed during launch. Others missed their targets or lost communication. Each failure added to a growing body of knowledge, even if that knowledge remained largely invisible outside the program. Gradually, reliability improved. Soft landings were achieved. Instruments transmitted data from the lunar surface. Images were sent back to Earth, revealing a world that had previously existed only through telescopic observation. The Moon became a place with texture, shadows, and measurable properties. The most significant achievement came with the return of lunar samples. Robotic probes successfully collected soil from the Moon's surface and brought it back to Earth. This accomplishment required precise navigation, automated drilling, secure containment, and controlled re-entry, all without human intervention. Few nations possessed the capability to attempt such a mission. Scientifically, the results were valuable. The samples provided insight into the Moon's composition and history. They contributed to a broader understanding of planetary formation and the early solar system. From a research perspective, the missions were legitimate successes. Symbolically, however, they existed in a shadow. A robot returning soil did not carry the same impact as a human footprint. The image of a person standing on another world was simple, direct, and emotionally resonant. Data and samples, no matter how impressive, could not compete with that. This imbalance shaped public perception. Outside the Soviet Union, robotic achievements were often framed as consolation prizes, evidence of technical skill, but also of missed opportunity. Inside the country, coverage was selective and restrained. The missions were acknowledged, but not elevated to the level of national triumph. The absence of a human landing remained conspicuous. Internally, the robotic program served a different purpose. It allowed engineers to continue advancing complex technologies without confronting the systemic barriers that had undermined the manned lunar effort. Automation, remote control, and reliability became core competencies. These skills would later influence orbital station operations and long-duration missions. In this sense, the robotic path was not merely an alternative, it was a foundation. The Soviet Union began to define success in terms of sustained technical capability rather than singular achievement. Consistency replaced spectacle. Endurance replaced distance. The Moon, once the ultimate objective, became a proving ground rather than a destination. Yet the emotional dimension lingered. Many within the space community understood what had been lost. The robotic missions, however sophisticated, were reminders of an ambition unfulfilled. They demonstrated what the system could do, and what it could not bring itself to risk. The Moon was reached, studied, and touched, but never inhabited. This distinction mattered deeply in the context of global competition. It marked a divergence in philosophy as much as in outcome. One path prioritized decisive symbolic victory. The other prioritized controlled progress and survivability. Neither approach was inherently superior, but only one captured the world's imagination. As the era of lunar exploration receded, the Soviet space program settled into its redefined role. It would continue to operate at the frontier of space, but within boundaries shaped by past experience. The final chapter of this story lies not in what was achieved, but in what remained. The legacy of ambition, secrecy, and adaptation would outlast the lunar race itself. influencing how space was approached long after the moon had ceased to be the primary goal. That legacy defines the final chapter. By the early 1970s, the Soviet space program had entered a different phase of its existence. The era of dramatic firsts was largely over. The moon was no longer the focal point. Instead, space became a domain of routine, persistence, and controlled ambition. This transition was not framed as a loss. Official narratives emphasized continuity and progress. New missions were presented as natural extensions of earlier achievements. The absence of a human lunar landing was not addressed directly. Silence, once again, became a tool of stability. In place of lunar ambitions, Earth orbit took center stage. The Soviet Union invested heavily in long-duration orbital missions. Space stations became the new symbol of capability. Rather than traveling farther, the focus shifted to staying longer. Endurance replaced distance as the primary metric of success. Programs such as Salyut program reflected this change in philosophy. These stations were not designed for spectacle. They were functional platforms for research, maintenance, and gradual expansion. Crews rotated in and out, experiments accumulated over time, and procedures became standardized. Spaceflight evolved from an event into a process. This approach aligned closely with the structure of the Soviet system. Incremental progress could be managed. Long-term presence could be controlled. Failures, when they occurred, could be absorbed quietly. The lessons of the lunar effort had been internalized, if not openly discussed. Technologically, the legacy was substantial. The Soviet space program developed expertise in docking, life support systems, orbital assembly, and human endurance. These capabilities would later define international space operations. Many concepts pioneered during this period became standard practice. Yet the emotional dimension of the earlier ambition never fully disappeared. Within the engineering community, the memory of the moon lingered as a symbol of unrealized potential. It represented a moment when technological capability had exceeded organizational capacity. The machines had been built, but the system had not adapted quickly enough to support them. This disconnect shaped future decisions. Caution became embedded in planning. Redundancy was favored over experimentation. Political leadership preferred predictable outcomes to dramatic risk. Space exploration continued, but within carefully defined limits. The broader public narrative followed suit. Cosmonauts remained respected figures, but they were no longer mythic pioneers. Spaceflight became familiar, almost routine. The sense of collective anticipation that had accompanied early launches faded into background awareness. Internationally, cooperation gradually replaced competition. Joint missions, data sharing, and standardized procedures emerged over time. The rigid divisions of the early Cold War softened, at least in space. Ironically, the domain once used to demonstrate ideological superiority became a platform for pragmatic collaboration. This outcome was not planned. It emerged from exhaustion, adaptation, and the recognition of shared constraints. Space, vast and indifferent, resisted domination by any single system. The Soviet Union's space legacy, therefore, cannot be measured solely by destinations reached or missed. It lies in the infrastructure created, the knowledge accumulated, and the people trained to operate at the edge of possibility. It also lies in the lessons learned about ambition and its limits. The moon was never walked upon by Soviet astronauts, but the attempt to reach it reshaped an entire technological culture. It revealed both the strengths and the boundaries of a system built on secrecy, scale, and control. In doing so, it left a quiet imprint on the history of exploration. When the Soviet Union itself ceased to exist, much of this legacy remained. Rockets continued to launch, stations continued to orbit, Engineers carried forward practices shaped decades earlier. The dream had changed form, but it had not vanished. In the end, the Soviet space program stands as a study in ambition constrained by structure. It reached farther than anyone had before and stopped where it could not adapt. That silence, surrounding both failure and success, is part of its story. And it is in that silence that the full weight of its ambition can still be felt.